Hi there. In this video, we will learn all about a junk dimension. A junk dimension is a special type of dimension table which is derived within the data warehouse. We will discuss why a junk dimension is required and how to go about designing it. Let's look at it with an example. Here is a subject area for traffic incidents. And here are some sample records for this transactions. So let's just quickly look at the columns. We have incident number, which is a unique number given to each incident. We have GPS coordinates where the event happened, accident intensity, brand, model, make and type of the vehicle involved, the date on which the event happened, number of casualties, if any, number of injured, and the reason for incident. So these are the data points that we are getting for these transactions. Now I'm assuming that you know the basics of dimension modeling. Applying the principles of dimension modeling, we arrive at these 6 tables, of which 5 are dimension tables and 1 fact table. The 5 dimension tables are vehicle, geography, date, reason, and intensity. And all of that connected to 1 fact table. And as in any fact table, this fact table here, which is the fact incidence, is connected to all the 5 dimension tables through foreign keys. There are 5 foreign keys, 1 for each corresponding dimension. Now let's look at the dimension table itself. Vehicle. The vehicle dimension has brand, model, make and type. All of these 4 attributes give different information about a vehicle, and hence they are all related and can be stored in one dimension. Similarly, geography, we have all the attributes of the geography hierarchy, such as country, state, city, and zip code. Again, all of these give additional information about the place where the event happened. The same goes with the date. But the other 2 dimensions, the reason and intensity, you will notice that there is only a single attribute in each dimension table. There are no additional attributes. So this is a very small and very less descriptive dimension table. Okay. Now let's look at the diagram for this. So this is your standard star schema representation of these tables. So we have the incident table, which is the fact table, surrounded by the 5 dimension tables. All right. So now let's look at the table design again. In a data warehouse, our objective is, or one of the objective is to reduce the number of dimension tables. If we have too many dimension tables, it means the user will have to join too many tables to get the data that they need. So as much as possible, we should try to simplify the data model. Now let's look at the data model. If you look at the dim reason and the dim intensity, they are not like the other dimension tables. There are no additional attributes. So can we somehow replace these 2 dimension tables with a single dimension table? One dimension table that will have the values of both. It's easier said than done, because you see the values here are not related at all. Unlike the vehicle dimension where the brand, model, make, they are all clearly related to each other, and so is the type. There definitely is a relationship between these attributes. The same goes with the geography as well, and same with the date. But here we are talking about 2 separate dimensions, reason and intensity. They are nowhere related, hence we cannot merge it into a same table. So that's a challenge we have. How can we overcome it? How can we force a relationship between the reason and the intensity table? We do that by applying a principle called Cartesian product. So let me scroll down. Okay, so what I've done here is I take the 2 dimension tables, dim reason, dim intensity. Then we look at the finite list of values here. right? So there are 3 records here and there are 3 records here. Now I'm going to create a Cartesian product. A Cartesian product is where we take one record from one table and associate it with every record in the other table, and this process is repeated for all the records in the first table, right? And you can look at this diagram to understand it more. So as a first step, what I do, I take the first value from the reason table, which is rash driving, and then I associate it with all the 3 values in the intensity: medium, high, low. Then I do the same thing for the second record here, which is low visibility, and associate it with all the 3 records on the intensity, and so on and so forth. As a result, you will eventually end up with 9 unique values. Now here you will notice that the reason does repeat, the intensity does repeat as well. However, a combination of reason and intensity value is unique, right? Now, creating a dimension table using these values, we end up in a table like this, where I have the reason, I have the intensity, and we can give a very generic name. Here I'm just calling it as a miscellaneous dimension, and I have associated a surrogate key as well. Now you'll see how 2 tables were forced into a single table by using Cartesian joins or product joins. Now let's see how this affects the data model. Now we are looking at the same data model. However, the change is that instead of dim reason and dim intensity, we now have a single dimension called the miscellaneous dimension. How we started with 5 dimensions, but now we only have 4 dimensions: vehicle, geography, date, and miscellaneous. Now what happens to the fact table? In fact table also, we only have references to the 4 dimension tables. You'll see that the dim miscellaneous has replaced the reference for the intensity and the reason. Creating a diagram for this looks like this. Now you'll see this data model is a little more simple than the previous data model, right? So we have one less table, which also means lesser number of joins. Now apply this example for any real world data warehousing projects, and you will realize the amount of simplicity that you can apply to your data model, right? Subject areas or data models that have lots of dimension tables can be reduced. You can reduce the number of dimension tables by applying the junk dimension concept. But what are some of the problems of creating a junk dimension, right? Junk dimension is not the answer for everything, right? So let's look at some of the problems that you'll have to be aware of if you were to create a junk dimension. So take this first example where in the intensity I have to introduce a new value called critical, right? With the intensity ID of 0, right? So the moment I add a value to the dim intensity, now the Cartesian product has to be revisited. Because why? Now it's no longer 3 into 3 equal to 9. Instead it's 3 into 4 equal to 12 records, right? So the product join is affected because of one new attribute that you added, which means you will have to rebuild your dimension table. What initially was 9 values now becomes 12 records, 12 unique records, uniquely identified by a combination of reason and intensity, right? So this is one problem, which means when you are about to create a junk dimension using existing dimensions, make sure that the list of values is pretty much static and it's not changing a lot. That's one thing to look out for. The next thing is, how do you deal with dimensions that are created newly? Now assume that we add another dimension called dim weather. right? And weather also has around 4 values, which means you now have to do a project join between all the 3 tables, right? And this diagram sort of illustrates what it would look like. So first, I will do a cross join between dim reason and dim intensity, and I arrive at these 12 values. And then I apply a cross join between this data set and the weather dimension. And you can see that I have already done it for 2 rows, but this relationship would apply for all the rows that are here. And the end result is a large table. I believe this has around 48 records, right? So this has around 48 records, and the resulting dimension table is this. So we went from 9 to 12 in our first step, and by introducing the weather dimension, now suddenly the number of records in your miscellaneous dimension has jumped from 12 to 48, right? So it's not advisable to add every dimension table to the junk dimension. If such as in this case, if a weather is a dimension that is later identified, it is better to keep it part of another junk dimension rather than merging it into the existing dimension. Because if you do, as you can see, your existing dimension will grow, as well as you may have to go back and update the existing records in the fact table. Alright, so this is the concept of a junk dimension. Thanks for watching this video. If you found this video useful, please do like it and subscribe to my channel. Thank you.